Okay, so hello. This video is going to be part of a series that I do on step mathematics. So if you don't know, step mathematics is an exam set by Cambridge University, and it's kind of a supplementary or extra exam for A-level students or students wanting to apply to Cambridge University. It's also used to a lesser extent by other universities in the UK. Anyway, if you want to know more about step mathematics, you can find out on the internet. And what I'm going to do is just look at individual questions, not choosing them according to any real pattern, but just if it looks interesting, maybe just to help people who are trying to prepare for this exam and don't have any teacher or just need some extra help. And okay, so this example that I've got here is from 2002. You can see at the top I've written the title Step 3 2002 question 5. So the 3 means paper 3 because there are 3 papers. And generally the main point about paper 3 is that it's sometimes, well, it does require knowledge of further mathematics A-level as well as mathematics A-level. Although some questions, including this one, you don't really need any special knowledge at all to do them. I mean, actually the knowledge needed in this question you could argue is already there at GCSE, although that's a bit of a stretch. Now, as well as actually solving the question, I want to talk about how you go about solving these, give you some pointers on that. Alright, so let's read the question. Give a condition that must be satisfied by P, Q and R for it to be possible to write the quadratic polynomial given in this form. Now, let's say that the question is divided into 3 parts. It seems to be. There's a part here, and then another part here, obtain an equation in this form, and then lastly, hence, write this, blah blah blah. So it looks like a 3-part question, and a very big, not clue, but a very big hint I want to give anyone who wants to do these questions is it's very useful to read the whole question, even though they're quite long and complicated. It's very useful to read the whole question before you start the beginning, and I hope that will become clear as you look at this example and others. So if you read the whole question, and I recommend that you pause the video, read the whole question carefully, and also try to do the question before I do it. Anyway, so if you read the whole question, what things do you notice? First, you'll notice that the whole question is about algebra. There's nothing about calculus, there's nothing about angles or trigonometry, there's nothing about complex numbers, and so on. It's a purely algebra question, and in fact most students will find that to be a good thing, because it's really quite limited what kind of knowledge they can draw on. Basically this is a question about algebra, and specifically about polynomials. So you might just reflect, what do I know about algebra and polynomials? I know about quadratic equations, I know about cubic equations. You should probably already know how to solve cubic equations. That should have been covered at A-level or even earlier. And of course I mean only solve some cubic equations. Now, equations of higher degree or polynomials of higher degree, such as the quartic equation, so you see here degree 4, you may not know very much about them, but you should probably know some general facts about roots of polynomials in general. So that's just about the preliminary knowledge, or the knowledge you need before doing the question. But then there's also the structure. You see that, for example, I would say especially this here, you see a very complicated structure. Now, step questions do not always contain complicated equations. Complication is not the point of step questions. But what's very noticeable is that they expect you to be more comfortable with complication than would an A-level student. So think from that point of view. don't be scared of complexity. Don't be scared if the question needs you to do a whole page of working instead of just 3 or 4 lines. Yeah, but at the same time, don't get attached to complication. Don't look for things to be complicated. Of course, any good mathematician will always try to make things as simple as possible at every step. So it's a very fine balancing act that you have to follow between accepting complicated problems but not looking for them. So anyway, you'll see that as you go through examples yourself. So yeah, as I was saying, it's a 3-part question. The first part is usually something quite easy. You could think of it as a warm-up, like when you're doing exercises. It's kind of a warm-up exercise. But although it's easy and it's a warm-up, it's often important. So I could maybe draw little arrows here. There's usually some feed through like this. So the first part may well help you with the second part, and the second part may well help you with the third part. I would go so far as to say that it's very unusual that you don't reuse the result of the first part in the second and third parts. Yeah. So I've already made a lot of comments about structure and topics and things without doing any maths. So I think maybe it's time to start doing some maths now. Let's actually do the first part and see how we get on. But let me repeat. If you haven't yet read the whole question, read the whole question without doing it. And the purpose is to try to get a feel for what is the examiner really asking. In fact, that's so important that I'll write it down. What is the examiner really asking? Try to get into the head of the examiner. Now, you won't always succeed, and sometimes you'll even be able to get a perfect answer, and only some hours later will you really realize and understand what the point of the question is. But it's definitely worth trying to understand the point, because if you do understand the point, you're going to be so far ahead of anyone else who doesn't. Yeah. Okay, so let's do the first part. Let's call the parts A, B, and C, even though they're not marked as A, B, and C on the exam. But anyway, so part A, I'm going to find a condition satisfied by variables P, Q, and R. And notice, by the way, that they don't say anything about P, Q, and R. In many cases in maths questions, we have to be very specific about the type of number we're dealing with, but here they don't say that, so okay, that's clear. So what condition must be satisfied by P, Q, and R for it to be possible to write the quadratic polynomial px squared plus qx plus r in the form p times x plus h squared for some value of h? Okay, so the first thing we should think about is, what is this form? What does this form mean? What is this? Okay, you should understand that this is a complete square. So a complete square is often a very useful structure because it has the quality that it's positive. Careful. This is not really a complete square, is it? Because it's multiplied by p, and p does not have to be positive. But x plus h squared is a complete square, and it must be positive. Okay, so it must be positive. So what kind of function is this complete square function? How does this relate to what you already know about quadratics? Well, I can only tell you what immediately sprung to my mind when I saw this. I thought, well, if I draw px plus h squared as a graph, actually this is minus h, isn't it? I've got a graph which touches the x-axis. And a graph which touches the x-axis has exactly one root, minus h. Yeah. And if a graph has exactly one root, then I know something about its discriminant. If a quadratic, I should say, has exactly one root, I know that its discriminant is 0. So immediately, without any more calculation, I can just use what I learned in secondary school. I learned that if the discriminant is 0, then b squared minus 4ac is 0. Now b squared minus 4ac here means, if we look, q squared minus 4pr. So q squared minus 4pr is 0, so q squared is 4pr. It's very simple actually. You could obviously use algebra to derive it, but all you would be doing is following the process of completing the square that is so well known. So as I said, this first part is easy. This second part, it looks a lot more difficult. Let's read it. Obtain an equation which you need not simplify. I'm going to underline that in red. Obtain an equation which you need not simplify that must be satisfied by t if it is possible to write this complicated formula in the form k times x plus h squared for some k and h. Well, obviously we notice that this form is exactly the same as this form here. It's a completed square form with a extra factor k. And what they're doing here is they're giving you quite a complicated structure, and you need to not be afraid of it. Yeah, you would never see this in A-level because they're throwing so many different variables at you. You've got b here, then you've got b, c, d, e here, and then you've also got k and h. But the trick here is that we don't need to know k and h. Yeah, so here the word sum for some k and h means we don't need to know k and h, so that's already something we don't need to do. Find k and h. And also I underlined this in red, which you need not simplify. So whatever we're going to do, yes, it will be complicated. But that's okay. It's okay for the equation to be complicated because we do not need to simplify it. I wouldn't say that's common, but it happens from time to time in STEP questions that the examiner realizes that what he is asking you to write down is something very complicated, but he does not want you to spend an hour figuring out the solution. Yeah, you just write the equation, you don't solve it. Okay, now let's look at the actual formula here. I think I'll have to write this by hand. So first of all we have x squared plus half bx plus t squared. Let's write it in the second page. X squared plus b over 2 x plus t squared, and then we're subtracting another quartic polynomial, fourth degree polynomial, which is x to the 4 plus bx cubed plus cx squared plus dx plus e. And what they're asking, this is part B, what they're asking us to do is to find an equation satisfied by t if this is of the form k, so let's say identically equal, because obviously x is a variable, this is an identity for x. So how are we going to use the first part of the question? Well, obviously we're going to use the result that this result here, that q squared equals 4pr for any quadratic function which can be written in the form like this. So part A tells us, that what was it? Q squared equals 4pr for a quadratic function. How should I write this? Perhaps I should not bother writing this in English because it will just end up being less than helpful, let's say. Tells us that tells us a condition on the coefficients of a condition on the coefficients of x squared, x to the 1 and x to the 0 for left hand side. So what I'm saying here is that we know that if the left hand side can be written in the form of the right hand side, then the discriminant of the left hand side is 0. Yeah? So i.e. discriminant of left hand side equals 0. Discriminant delta of left hand side equals 0. Now you may have missed an important point here, that the left hand side is a quadratic function. So maybe I should write this in brackets. It should be quite obvious, but left hand side is quadratic because x to the 4 and x to the 3 have coefficient 0. Yeah, we see on the left hand side that the coefficients of coefficients of x to the 4 come from here, x squared squared minus x to the 4, so that's 0, and then b over 2 times x squared times 2 gives me bx cubed minus bx cubed, so I get in total 0 x cubed. Something is going on with, oh, that's my mouse, isn't it? Sorry, my mouse is moving. Maybe if I put that, okay, there we go. So we can simply consider the coefficients of x squared, x, and the constant term on the left hand side. Let's look at the coefficient of x squared. This is the messiest part of the question, I think. So left hand side, coefficient of x squared. Well, I'm going to get x squared times t twice, so I get 2t. But I'm also going to get x squared from this second term multiplied by itself. So that's b over 2 squared. And we don't get that twice because it's the same term, if that makes sense. But then we also have another x squared term here, so that's minus c. The coefficient of x to the power 1, well, here we would only get x to the power 1 by multiplying this term and this term. So we get b over 2 times t times 2, so that's bt. And here we get minus d. And the constant term on the left-hand side will be t squared. So constant in this part is t squared, and then minus e. So if we combine that information, we get the discriminant, or delta, if you prefer. Slightly complicated structure, isn't it? We've got b squared, so that's bt minus d, the coefficient of x squared, minus 4 times the constant term t squared minus e times the coefficient of x squared, which is 2t plus b squared over 4 minus c. So all of that must be equal to 0. And this is the required condition for t. If I can just make a bit more space. This is the required condition for t. So I'm writing a few extra notes in English here. Generally speaking, it's useful to write a little bit more in English in some step questions than you would in an A-level or normal exam, because the concepts are a bit more complicated. Anyway, this wasn't too bad. All we did was repeated the principle given in the first part here, which you need not simplify. So okay, it was complicated. We see here a complicated condition for t, an equation for t. We notice actually that this is a cubic equation for t. But we're not going to solve it here because we have all these letters B, D, E and C, which is a bit annoying. Alright, now let's look at the third part. This is usually the most important part of the question, and it's always noted on the front of a step exam paper that you are encouraged to write complete solutions. And the reason I think they say that is because it's almost always the last part of the question that has the real quality to it, the really difficult part, the part that requires thinking. So there's a couple of things to notice about this third part. First of all, the word hence. It's very important because in each question the examiners decide, should we require that the student use the method given, or is it acceptable for them to use another method? And I would say that the majority of the time, maybe 75% of the time, they require you, as they do here, to actually use the result of the previous part. Now, the other thing to notice about this third part of the question, which is again very common, is they're not giving you any clues, or at least it's difficult to say this. They're not telling you how to do it, but they certainly are giving you a clue in as much as by saying hence they're telling you that you should use the second part to do the third part. If you find a way to do it any other way, well, great, good for you, but that's not going to get you credit, because they're telling you what to do and you have to do it. Now, the reason I wanted to write no clue is because it's usually not at all obvious, or not, let's say not very obvious, how you can use the previous part to solve the last part. So how can we use this rather strange formula, and then this complicated formula that we've just picked up for sorry, just get my mouse working. This complicated formula that we worked out here, how is that going to help us to do what they're asking in the third part? So they're asking, write this quartic polynomial, quartic because degree 4, as a product, notice the word is product, not sum, as a product of two quadratic factors. Okay, so the question makes sense because a quartic polynomial, degree 4, must by definition be factorizable. Sorry, hold on, let me get that straight. Yes, as long as we include complex numbers, this is true. It must be factorizable into two quadratic factors. In fact, even without complex numbers, that's true, according to Gauss's fundamental theorem of algebra. But anyway, let's not get into the theory of polynomials. The idea is, how can we write this in the form of two quadratic factors? So they're saying, how can I write, let's just copy it down, x to the 4, whoops, forgot, what was it? X to the 4 plus 6 plus 9 minus 2 minus 7 plus 6x cubed plus 9x squared minus 2x minus 7. Did I get that right? Let me check. Plus 9 minus 2 minus 7, yeah. So they're asking us to write this as a product of two quadratic factors, so it will have to be something like x squared plus ax plus b times x squared plus cx plus d for some constants a, b, c and d, which we should determine. Now notice I just put 1x squared here and 1x squared, and that must be true because here we have x to the power 4. So this is what they're asking us to do. How can we use the previous result to do it? Now let me try and show you my logic. I found this fairly easy myself, as step questions go, because there was really only kind of one thing to do. So what do I mean by that? Well, we've just been told how to rewrite this in this perfect square form. So since this is a quartic polynomial of the same form, so since this is a quartic polynomial of exactly the same form as this, it's obviously intended that we should write b equals 6, c equals 9, d equals minus 2, and e equals minus 7. Having done that, we can write this, so it would be like x squared plus 3x plus t squared minus x to the 4 plus 6x cubed plus 9x squared minus 2x minus 7 equals k x plus h squared, just as they've written here. We know that must be possible. But what they're asking us to do is to write the blue underlined quartic here as a product of two quadratic factors. But if I write this minus this equals kx plus h squared, what I've got is this quartic polynomial as a difference, not a sum of two quadratic factors. So let me try and explain that with visually as well as with words. What the second part of the question will allow us to do is to write something like x to the 4 plus 6x cubed plus 9x squared minus 2x minus 7 is equal to, and again it's an identity, now which way around is it? Okay, x squared plus b over 2x plus t squared minus k x plus h squared. But the first thing, well not the first thing, it should be obvious that the way we can get from here to here is to use difference of two squares. And that will make sense because if both of these are, this and this are quadratic functions, then if we add them together here, or if we subtract them, we're going to get another quadratic function. And so everything should be okay. We should get a product of two quadratic factors. So although at this stage you're not completely sure that it's going to work, you can see there's only really one path you can go down to use the previous result in order to get the final answer. So you just get on with it, yeah. So you first of all you set the values of b, c, d, and e. So according to what we're given, b is 6, c is 9, d is minus 2, and e is minus 7. And then you try to reuse what you've already done, which is that you wrote the discriminant. So you just write the discriminant. Let's write discriminant, delta for discriminant, and I'll copy this formula that I already derived here. Whoops, is that right? Actually looks about right. Yep. Let's copy this discriminant out. Paste it here. Oops, sorry about that. Okay, discriminant here, something like this. So if discriminant is 0, oops, there we go. Then I can simply replace the values of b, c, d, and e, and I'll have an equation in t. Yeah. So I have 6t minus, what's d? Plus 2 squared minus 4. T squared minus e, that's t squared plus 7. Now I've got 2t plus b squared, that's 36 over 4, that's 9, minus c, which is 9, which is 0, equals 0. So this should be no problem because, well, I say no problem, but this is a cubic equation in t. So if I can find a particular value of t for which this discriminant is 0, then it must be true that I get a perfect square on the right hand side of this equation up here. Yeah. So if the delta on the left hand side is 0, then this will be possible, and there will be a certain value of k and h which makes it true. So I simply try and solve this. Now you know a certain method to solve cubic equations. Let's see if it works. Let's take out a factor of 2 here. So I've got 2 times 3t plus 1 all squared minus 4 t squared plus 7 2t. Then I get the 4's cancel, so I get 9t squared plus 6t plus 1. 4's cancel, so that's minus 2t cubed, and I've got plus 14, 14t, that's minus, isn't it? Minus 14t equals 0, so just tidying up, I've got 2t cubed minus 9t squared plus 8t minus 1 equals 0. So here's my cubic equation in T. It may have 3 real values, but it has solutions, but it has at least one real solution. And this is a particularly easy one. We can easily see that if we set T equals 1, so therefore T minus 1 is a factor, or T is a solution. T equals 1 is a solution. So let's try and follow the logic again here. If T is equal to 1, then the discriminant is 0. And if the discriminant is 0, then this equation we wrote here will be true, this identity will be true for a certain value of k and h. So if we find those values of k and h, we will have the form that this quartic polynomial is equal to the difference of two squares, or difference of two squares of two different quadratic functions of x. Then we can use the difference of two squares formula to rewrite that as a product. Okay, so let's do that. How am I going to do that? I guess I should probably just copy this back. Yeah, there we go. If I copy this that we wrote in part B again, and our next task will be to set T equals 1. So in this equation, set T equals 1 and find k and h. Now we already know B, C, D, E, so we know T is 1, so it should be easy to find k and h. Let's rewrite it with numbers. X squared plus b over 2b is 6, so that's 3x plus 1 squared minus. Actually, why don't I just write this as I need the numbers. X to the 4 plus 6x cubed plus 9x squared minus 2x minus 7 is identically equal to k x plus h squared. And because this is an identity, we can just compare the coefficients of the polynomials on the left and right hand sides to find k and h. The first one should be simple. If we want to know the value of k, we can compare coefficients of, so we're using the technique of comparing coefficients of, let's say, x squared. Well, on the left hand side we've got, what am I doing there? How many x squared do I have? Oh, I see. 1 plus 1 plus 9, isn't it? 3 times 3, yeah. Minus 9 equals k, so k must be equal to 2. Now let's compare coefficients of the of x itself. So I've got 3x plus 3x, 6x plus 2x, and that should be equal to 2kh. K is 2, so that's 4h, so h is 2. So finally we can rewrite this as that the quartic polynomial we're given is identically equal to the difference of the squares of two quadratic polynomials, x squared plus 3x plus 1 squared minus 2x plus 2 squared. Now I could write that, now that of course we don't want this 2 here because we want 2 perfect squares, so I have to rewrite that as a perfect square. X squared plus 3x plus 1 squared minus root 2x plus 2 root 2, there we go, squared. Yeah, because that would be, yeah. Okay, so using difference of two squares, that would be the same as, this is going to be quite long, x. So first let me take the sum of these two quadratic, oh sorry, did I make a, no, that's right, yeah. Yes, of course. X squared, sorry, I know what's confusing me here is that I kept saying the difference of the squares of two quadratic factors. Actually, they're not the same, are they? This is a quartic and this is a quadratic, but they're both perfect squares. Yeah, that's the point. Sorry. So here the sum of this function and this function is x squared plus how many x? 3 plus root 2 x plus 1 plus 2 root 2. And then the difference of these two functions is x squared again, but now it's the difference, so it's 3 minus root 2x, and we've got plus 1 minus 2 root 2. Okay. So I'll stop there. So that is actually the answer that we're looking for, unless I've made a silly mistake. So let's have a quick review here. Looking back at the question, a few points. It's paper 3, which means it might require further maths knowledge, but when we look at the content we see it's all about polynomials. So it only requires algebra knowledge and polynomials. There's a 3-part structure, which is a very traditional structure for a step question. First part, an easy proof. Actually, this one is a bit easier than usual. I've seen some that really take some work, but this is a very, very simple one. The second part looks complicated, and it's deriving some specific result which you wouldn't guess on your own. I mean, certainly, if you were asked the third part of the question, reflect on this. If you were asked to write this function as a product of two quadratic factors, you might do all kinds of things, but you certainly wouldn't think of trying to make a structure like this, I think. So that's interesting. And then doing the third part, we're told that we must use the second part. So overall, in review and summary, I would say this is a simple question. It's really quite an easy one. When I did it before the video, it took me, I don't know exactly how long, but you know, bear in mind you've got basically half an hour to do these questions. And there will be times, if you're lucky, when you only have to spend maybe 15 minutes. And this is probably one of those times. But you need that if you're going to get a good score, because some other questions will really force you to struggle. And the third part, it looks like it's not giving you many clues, but there's only really one slightly unobvious idea, which is that you should treat these two functions that you get at the end using the difference of two squares formula. Yeah, so I think I'll leave it there. Hopefully that was useful, so thanks very much.